All right. Hi, everybody. We're going to do a quick review of basic computer hardware. So this is a little goofy because normally I'm using this computer setup, but I had to power it all down so that I can open it up and show you kind of what's inside. So I'm using this device. So let's turn this and we'll take a look at the inside of a computer. As you can see, I pulled off both the side panels. So here is one of the clear side panels that would cover this side here. So still on the CN, but tinted. I've also taken off the front cover so that we can see the front. And you notice with a quick once over that uh, really a case is just a metal box. It's a metal box that has lots of holes that are pre-drilled and in precise positions to make it easier to mount and attach things. But other than that, it doesn't really do anything other than kind of protect the components, allow you to mount things really easily. So let's take a look at some of these components that are inside. Now, I know it's a little tough to see, so I'll zoom us up a little bit. This whole background here, this whole back area is all what is called the motherboard. And the motherboard looks like the fanciest part of a computer, but it's really one of the least important. Important in the sense that it doesn't really do anything other than connect the parts that do things. So if you look in the back, there's lots of tiny little lines. This whole board is an insulator, meaning that it does not conduct electricity. And embedded in it are wires that connect to pins and ports and things so that they can communicate with one another. So you notice that there's some components that are connected with big sets of wires, but the board itself is connecting, say, this device to this device to this device, are all being connected that way. So up at the top here, one of the most important pieces that you can't see because it's covered by this fan that is on top of a heatsink is the CPU, the central processing unit. That is the part of the computer that does the thinking. It actually executes commands. It is the piece that makes everything on your computer function or able to do something. So that piece is buried back here because it gets very hot when it's operating, and keeping it cool is very important. Now, just below that, we have a small hard drive. Now, this is a hard drive in the M2 slots, NVMe hard drive, which makes it very quick. I also have here in this static bag, let me hold up. This is a 2 terabyte disk platter hard drive. So notice this thing is big. It's pretty heavy, and this is a more traditional style hard drive, but it's slower than the NVMe, which is that's a 500 gigabyte drive. Now, NVMe is a little bit more like this. This is also a type of hard drive. However, the drives that like solid state drives and flash drives, they tend to fail after so many read and write cycles, whereas a platter drive is a little bit more reliable. It's also slower. So this is great for installing big programs that you're not constantly opening and closing. It's great for putting files that you want to make sure never get lost, but you don't need very often. Whereas the NVMe is going to be great for having your operating system that won't be changing very often, but you're going to be loading it all the time. Now, up here we have two pieces of RAM that stands for random access memory, whereas your hard drive is your long-term storage, so keep files that I'm going to have around for a long time. Your RAM is your short-term memory, so things that are copied on your clipboard, the images that are currently on the screen, the sounds that are currently playing, things that are relevant to what your computer is doing right now, but may not be later on. So the important thing when considering RAM versus storage is that RAM is volatile. When the power goes off, everything that's on here goes away, whereas your storage will still function after the power goes off. You don't lose that information. So RAM helps you to manage the things that are going on right now, and storage allows you to keep them for later. All right, so both your RAM and your hard drive are storing information. Your processor is processing information. Now, this big thing here is a video card. This is not necessarily needed, but oftentimes, especially with gaming rigs or computers that are built for doing CAD modeling, graphics matters. Rendering things to your screen that are complicated can slow down your computer. It can be a task for your processor. So a graphics card is similar to a CPU. This is called a GPU, graphics and graphics processing unit. But a GPU can do many simple things in tandem, whereas a CPU can do one complex thing at a time, where if you have multiple cores, a few complex things at a time. So CPU is going to handle complex tasks. A GPU is going to handle really simple tasks. For example, determining what color each pixel on your screen should be. That's a simple process, but you have thousands upon thousands upon thousands of pixels on your screen, maybe even millions depending on your resolution. So the GPU it helps handle those. And again, because it is a big device, you can see all these fins in here are all heat sinks to help cool it off. And also you can have active cooling with fans and other cooling systems. Up here, we have an optical drive, and I'll give you a front view of that too. So if you wanted to put a CD in, that is a means for getting information into your computer. We also have USB drives both on the top and the back. It's another means for connecting to the computer. You can't see it on this side. Let me turn you around. But on this other side, you can see the power supply down here that takes in power from the wall, so from this outlet, and then we'll convert this 110 volt alternating current to direct current. So like 12 volt signals or 5 volt signals. The power supply is a very important part of your computer because all of these devices use electricity to function, but they need to use electricity in a very prescriptive way to function. You couldn't just wire these directly into the outlet on your wall and fry them all. One, because most of them use direct voltage or direct current instead of alternating current, and also because you don't want the voltage to be very high. For most of these things are not very powerful. They're just trying to send a signal. That signal doesn't need to have a lot of energy with it. It just needs to be noticeable. So again, big parts that we have in here: CPU for thinking, your GPU for graphics processing, your hard drive for long-term storage, your RAM for short-term storage or short-term memory, your motherboard to connect them all together, power supply to allow it to turn on and give you the right amount of power, an optical drive if you want to have one that's optional, and then we have some other case fans for cooling off, and power it on, and there we go. We got a simple computer. All right. Hope that helps. Bye now.